water, H2O, you have the ratio of 2:1. Okay? If you have your sodium chloride solution, so this is your 1:1. It is a fixed ratio. So for the mixture of two or more substances, we have your homogeneous mixture, and the example of this is your solution and your colloids. So heterogeneous mixture is the components that are in varied composition, wherein you can see and identify each of the substances before and after mixing it. And this is your heterogeneous mixture. Okay? So you have your classification of compounds according to the chemical bonding. So this could be your transfer of electrons. The bond exists between them is ionic. And we have the sharing of electrons. The bond that exists between our atoms would be your covalent bonding. And there are types of covalent bonding. When the sharing of electrons is of electrons in the same type of atom, that is what we call nonpolar. If the sharing of electrons is between unlike atoms, this would be your polar covalent bond. So we have in your book, you have there the table wherein you can range it as 0 to 0.49. This is the electronegativity difference of classifying the compound as nonpolar. If the difference, electronegativity difference is from 0.5 to 1.899, so this is considered your polar. And if it is 0.99 and above, this would be your ionic compounds or ionic compounds with ionic bonding. If we have to classify the compounds based on electroconductivity, we have the electrolytes and non-electrolytes. Okay? So the electrolytes are again split into two types. This would be your weak electrolyte and your strong electrolyte. So if the electrodes are submerged into the solution and it gives a strong light ang ating bulb, this is what we call your strong electrolytes. If it will give the solution when the electrodes are dipped into it and it gives up dim light, that is your weak electrolyte. And if the solution will not give light when the electrodes are submerged into it, and that is what we call your non-electrolytes. So if we can classify compounds according to properties, this would be the property of acids, bases, and salts. So if you can remember mga bata, if strong acid and strong base combine together, it will form water and salt. Tama? And this is the process of neutralization. And you can relate this with the type of chemical reaction that is what you call your double decomposition reaction, your double displacement, or your double decomposition. So did you discuss this in the lecture? Sino nga ulit ang lecturer natin? Si Sir Nabwa? Tama ba mga bata?
Yes po, Doc.
Okay. So, I know siguro you have done this in your prelim. Ayan ang classification of matter. For physical changes, this could either be your extrinsic and intrinsic properties. So, pag tinawag na intrinsic properties, these are the inherent. So, that would be the internal composition and identity of the compound. If it is extrinsic, that would be your external view. So changes in physical properties as that's of size, shape, and density, or changes in the state of matter without accompanying change in composition. Okay? So the tearing of paper, the change of ice into water, ito yung change of water into steam, and heating platinum wire. So no new substances are formed. So intrinsic property of matter is an inherent quality that does not depend on the amount of substances present, does not depend on the amount. So it is not referring into the size. So these properties are determined by the material's fundamental chemical composition and structure as it is. So density, the boiling point, melting point, kasi kagaya ng, repair natin yung density and boiling point ng water. The density of water is 1 gram, 1.00 gram per ml. 1 ml is equivalent to 1 cubic centimeter. So the boiling point of water is 100 degrees Celsius. Kahit ba gawin natin 1 liter yan o kaya 250 ml or 1 gallon, ang ating papakuluing tubig, hindi magbabago ang boiling point ng tubig. It is not affected upon by the size or amount of the object. That would be the same thing with melting point. Color. So, there are times yung color kasi medyo kagaya ng green apple na nakukuha sa China, green apple. Pag sa US naman, red apple. Pag nasa Japan naman, anong apple meron sila? Diba? Fuji apple. Okay? Then, yung odor. So, ito yung mga scent ng ating flowers. Diba? Odor ng, pero ngayon iba na eh. Yung rose, mga ganon. Pero ngayon iba na, diba? Minsan, mga scent natin represented by the individual character, yung mga celebrities na. So, also for crystal structure. So, yung crystal structure natin, example, ito yung ating salt, crystal. Anong nakikita pag crystal? May luster. At titigan mo yung salt na mga granules natin. May kinang siya pag tinamaan ng ilaw. Okay? Then, another example or another characteristics of physical property is extrinsic property. So, yung extrinsic property, this is affected upon by the mass. So, gaano kadami. Then, the volume change depending on the size of the sample. Kagaya nito, if you have only 1 by 1 square meter of gold, diba? So, the mass, pag yan ay lumaki, it would be 3 centimeters by 3 centimeters. Kanila 1 centimeter. Pag lumalaki ang mass, lumalaki din ang volume na inoccupy ng solid mo. Kaya, it is your extrinsic property. Okay. So, babalikan ko kanina yung ating physical properties, such as the size and shape. Pag pinag-usapan ng size and shape natin, ito yung extrinsic. Pag density ang pinag-uusapan, ito yung intrinsic. Pero sa ibang books, it is mentioned as extensive, intensive. So, pareho lang yon. Internal property, external property. Okay? For the chemical changes naman, it is a chemical change wherein new substances are formed that have different properties and composition for the original material. Okay? So, you have that. Ito yung ating samples na ginamit sa ating laboratory. You have your glass tubing, the iodine, the magnesium. Okay? Then, we have it. Ito yung ating glass tubing when we have to light it. So, before and after, ito yung kanilang itong kanilang visible appearance or description. Before reaction, before heating, it is a transparent hard glass. During the reaction, after heating na yan. Kasi pag when the glass tubing is heated on a certain area, syempre nagra-radiate naman talaga yan. If this is the part wherein you want to bend, it is directly heated here at this part with your use of fish tail. Ano yung fish tail natin? Ito yung wing top. Anong purpose ng fish tail or wing top? Ito yung nagsispread ng flame. In order that pag nagsag yung ating glass tubing, it would not just be in one area. And it is easier to bend the glass tubing if the heat is not only focused on one area. Kaya ang sagging now, it's not only directly at the middle, but it will spread out somewhere around it. Okay, so it is easier to bend at a certain angle. Kung meron tayong 90 degrees, meron tayong 45 degrees, mayroon tayong 130 degrees na bending of glass tubing. And this is very important pag ginagamit natin sa simple distillation process or kaya doon sa heating of, distillation, meron din. Distillation, at saka yung isang carbon-hydrogen test. So after heating, when it comes to the component, still the same. Okay? Wala siyang pinagbagong component. For the iodine crystals naman, ito yung ating violet crystals. Nakikita, andi dito yung crystals natin. When we heat it, when we place it into the test tube, stoppered ito, nakastopper yung test tube natin while heating. So the change, yung solid, will form into a gas colored purple. Okay? So when you set it aside for quite some time, yan ay magiging fumes yan dyan sa loob. Kaya na-stopper siya para hindi siya mag-escape to the surroundings, and we will observe what will happen after it cools down. So when the test tube cools down into a lower temperature, what we can observe this time, yung fumes, you can see here the small particles that are sticking on the upper part of your test tube. So what does it mean? That the gas, ito kasi kanina, solid changes to gas. This time, your gas changes into solid. Okay? So we have here solid changes to gas. So this is, kumbaga, ito din yun ang ating from the state of matter. Solid, liquid, and gas. Solid to liquid, melting process. Liquid to gas, it would be your evaporation. Tama? Solid to gas, it is your sublimation. Gas to solid is what we call your deposition. Okay, sana maalala niyo. Then for the magnesium ribbon, the characteristics is before heating, it is here the shiny gray strip solid. Pero binigay ko sa inyo yung parang yun ay black. But when you scrape off, pag yan ay na-scrape natin yan, ito yung nasa loob, the gray strip solid. So during reaction, it was ignited, forming a white smoke. Diba, nilagay nyo to directly into your evaporating dish ba or your watch glass. So in the watch glass or your evaporating dish, you can see now your white ash. So there is the change of composition na. Kasi you have your magnesium ribbon. How does your magnesium ribbon ignites? Because of the oxygen of the surrounding reacts on it to form now your magnesium oxide. So the component now of the magnesium ribbon before and after heating, they are different. So it is a chemical change. Then you have your copper sulfate, you have your zinc, and you have your sodium chloride. Ito yung mga samples. Actually, some of these were not being used kasi ginamit natin sa iba. Okay, so na-shorten kasi yung ating time dito eh. So yung copper sulfate natin, ito yung blue colored. Kaya yung ating swimming pool, bakit blue color, bright blue color, or sky blue color ang ating tubig? It's because merong component yun ng copper sulfate. Para kahit paano, mai-enhance ka na napakalinis ng tubig pag ikaw nasa swimming pool. Okay? So you have your blue crystals. So crystals, ibig sabihin, it has luster when the light strikes on the surface of the material. Then blue color to gray due to the removal of water. So ito yon. By heating yung crystals mo sa test tube, you can see na ito ay yung blue mo, unti-unti siyang nagiging lessened, nawawala yung kulay. And you can observe at the upper portion ng test tube mo, andi dito yung droplets of water. So yung copper sulfate, ibig sabihin nagbigay at nag-separate into copper sulfate crystal and your water molecules. So it returned to the blue colored crystals. Kasi ito yung copper sulfate, dibang binigay sa iyo ay may pentahydrate. So when heat is applied, nag-separate yung copper sulfate mo plus yung 5 moles of water. So it's, kumbaga, decomposition occurs. So that is your chemical change. Gray silver metal ang ating zinc. When we place it into the test tube of hydrochloric acid, 6 molar ito, 6 molar HCl, it forms bubbles. Mayroong bubbles tayong nakita. And the bubbles is the release of hydrogen. Ito yung na-release. So yung product mo na ngayon ay zinc chloride plus hydrogen. So there is a change in composition. Then for the sodium chloride, when you place it, kasi dapat ito ay nasa tansan, cover coat, yung metal stopper or metal cover ng ating soft drinks. Kaya medyo mahirap na yun, hanapin. Kaya I tell you to use na lang yung ating test tube na maliit. Heat it up. So observe before and after heating. Still, ang ating crystals, before and after heating is the same. It's a homogeneous mixture. Hindi siya na-dissolve. Okay? Ito yung ating sodium chloride solids. Okay. Next, you have the table sugar and your barium chloride and your ammonium chloride. So, barium chloride is also in a form of solid. But if we have 1 molar barium chloride, this is where we have now yung ating solution. We only have to mix a certain amount of the barium chloride into 1 liter of solution, of 1 liter of your water or your solvent. So this is where we have the expression now of your solution in terms of molarity. Then your table sugar, ito yung common nating white sugar. So also it has luster, di ba? The ammonium chloride, so this is more an amorphous. It seems it will not give off light or luster when light strikes on it. So it is more on powder ang characteristics. So amorphous. Kasi yung solids natin, dalawa ang ating classification ng solids. You have the crystalline at saka meron kang amorphous. So yung amorphous natin, ito yung dull. Wala siyang luster pag yan ay tinamaan ng ilaw. So the seventh, ito yung ating chemical property, an observation with the sugar. So the table salt, C12H22O11, kasi it composes your fructose, saccharides natin, at saka yung glucose. Okay? Kaya yung glucose natin, ito yung kailangan ng katawan. At a normal level lang. When the glucose level in the blood is exceeding that of the normal level that we're in the body, kumaga, is using. So ito yung tinatawag natin, ang pasyente ay nagkakaroon ng diabetes. So dalawa din ang type ng diabetes. Yung diabetes 1 and 2, mellitus ba yun acquired at saka by genes. Okay, so this time, we have to dissolve the sugar in water in your beaker. So definitely, like dissolves like ba? Ang ating kumbaga yung water natin is inorganic substance. Ang ating sugar ay organic substance. Why it dissolved? Because this is the quality and characteristic of water that it can dissolve both. Kaya tinawag siyang universal solvent. But napaka-limitado. There always be a limit regarding how many carbon atoms of the organic compounds that could be dissolved in water. And one of that is sugar. Okay? Ethyl alcohol, pag nilagay mo sa tubig, it will form one layer din lang. It's a homogeneous mixture. So it can dissolve in water also. Although your ethyl alcohol comes from the sugar cane, it is from organic compound. It could be dissolved in water. But I mentioned this mga bata, because we have the rule in solubility that like dissolves like. But there are always, mayroong tayong exemption to the rule. Okay? So the barium chloride, when it is added to your potassium sulfate, barium chloride solution to. Potassium sulfate solution. So they are both colorless liquid. Then, when we combine it together, this is where we can observe the white precipitate. So the process is what we call precipitation. Dinidiscuss ko ng mga bata. The process is precipitation kasi liquid substances forming a solid particles, so that is what we call the precipitate. So the product of precipitation is a precipitate. Your ammonium chloride, this is a white crystals that when you place it into your test tube at a pinch amount, it's only a very small amount in 3 ml of water. So this is where can we observe that the sides of your container feels cool, cold, right? It's cold. So it is your endothermic reaction. Endothermic reaction. Then you have here, ito na yung mga classification properties or what. So, for heating the test tube, property that changes the shape kasi may sagging effect. The type of change is physical, and the explanation composition did not change. Heating of iodine crystals, the state of solid to gas. Physical change because composition did not change because yung ating gas turned into solid with the same property as that of your iodine crystals. The magnesium ribbon, the one that the part of the substance that changes is the composition. It is chemical. And your formation of magnesium oxide, ito yung white ash or yung gray ash. Then heating of copper sulfate, the change that has been specific is with the color from blue to gray-white or gray or white solution, white crystal. Then it is a chemical change. There is the decomposition reaction. Copper sulfate, kumbaga, hydrolyzed, it will be with your 5 moles of water. Adding sodium chloride to solution, it's still physical. Only your sodium chloride dissolved in water. How can we recover the sodium chloride in water? Supplied by evaporation. So heating of sodium chloride solution still physical change because yung liquid ito yung ating sinabi ko, itong mention ko kanina that we can recover the sodium chloride in water by the process of evaporation. Still the residue is with the characteristic of your salt. Then putting sugar in water, it's also physical change, dissolved. But heating the sugar, it is a chemical change because yung ating sugar, you have your C12H22O11. Heat is applied into it. It will form carbon plus water. So you can balance the equation. How can we balance it? By finding and writing the number of coefficients in every atom that is in our reaction. Okay? So by adding the potassium sulfate and barium chloride solution, it also changes in composition. Here is potassium sulfate plus your barium chloride. This is where we have the changing of partners. It becomes KCl plus your barium sulfide. Ito yung white precipitate na nakikita natin. It's the barium sulfide. Okay? So, adding yung sodium chloride to water. Ito yung nagbago ay yung state, the temperature, and the energy. So, dahil pag nilagay ang ammonium chloride in water, it ionized into ammonium ion plus your fluoride ion. So there is decomposition or the formation of ions in order that the state will change into ions. And this is what we call your chemical change, and the energy that accompany it is your endothermic reaction. Ito yung mga balance equation. I would not, okay. So, there are times mga bata ang ating sugar pwede ding magbigay ng carbon dioxide. No? Okay. So, we have it. So, next is we have your 2.2. Ito ba yun? Yung 2.2 natin ay yung ano bang 2.2 natin? Ito yung hindi. Wait lang, baka hindi ko na, wait lang, kamali ba ako? 2.2 types. Wala tayong 2.2. Wait lang, ano yung 2.2? Wait lang ha. So this would be pertaining to the techniques. So this would be your 2.2. 2.2. Laboratory processes and techniques. Okay. So the main objective of this activity is at the end of the activity, the student should be able to perform laboratory processes, applying the proper laboratory techniques, and to improve skill in doing laboratory processes. So ikaw, kaya it is a student-centered session ng lab kasi ikaw ang gumagawa, di ba? With the proper guidance, of course, with the pre-lab discussions and precautions, that would be done by following your procedure. Okay? So this is by handling solids. So how will we transfer solids from one bottle to another? Do not place the solids into your vial kasi ang vial natin ay maliit lang yung mouth. It must be placed in a wide mouth bottle. Meron talagang wide mouth bottle. Or it would be, since our available container wherein we can place the solids natin is your watch glass. So ito yon lalagyan mo. Pag occupy ang watch glass ginagamit ng iba, then you can take your bond paper, your clean bond paper wherein you can put all the samples natin, solid samples into it. So weighing, do not put the substance directly on the pan. It must be with your watch glass or with your clean bond paper, 1/4 or 1/8 bond paper. That could accommodate yung ating solid na i-weigh. So you have to weigh, ito yung ating weighing, weigh a piece of paper on the container. And then, balance it. Okay? So dapat palagi yung papel, don't have it in mind that papel lang yan, magaan lang yan, still it has the weight. You must be aware of, kahit yan ay 0.2 gram or 0.15 gram, still it is part of the weighing. At it must not be deducted from the weight of your substance. Okay, so you transfer solid from one container to another using at least two techniques. So, pag yan, you have to rotate the contents. So, parang nakikita mo sa bartender, pag liquid, di ba? Kaya, ikot nila in order to control and to minimize and to decrease the flow of the volume ng ating substances. Okay, so ito naman yung handling liquids. This could be done from transferring at least, you also use. So pag liquid naman, you have to use your steering rod in order to guide the solution coming from the stock bottle. But I am not requiring you and I am not encouraging you to use the dropper. You have to use dip the dropper directly to the stock bottle. That is not good. That is not a big that is a big no for me because contaminants could directly contact with the solution in the stock bottles. Or this is where if it is a small bottle lang naman ang ating stock bottle, then you can directly uh, minimal amount. Siyempre, what I always advise you is to place the content or the liquid into the vial, bring it into your working area or your table, and that's the time that you have to measure it using your graduated cylinder. Take note of the cover, mga bata. You don't have to put the cover directly on the surface of the table, but rather it would be the outside portion of the cover that lies on the table, okay, to avoid contamination. Then for heating, handling liquids, heating liquid in a test tube without spilling. So, it must be at 45 degrees. Inclined position ang 45 degrees. Ang inclination ng test tube. Then, the test tube must be moving back and forth over the flame. So this must be the mouth of the test tube must not be pointing to the anybody's or to the members, any member of the group's face. Point away from people, including ourselves. So agitation by swirling gently, okay? Move it back and forth over the flame. And hit side of the test tube to avoid bumping, not directly at the bottom. That would be our precautions. Then for handling solids, example, we have to weigh here at 3.4 grams. We don't, pero tayong isang spatula lang eh. So what we have to do first is to weigh the empty glass, watch glass. If the weight of the empty watch glass is 16.9 and the spatula of your salt place on a spatula. So yung spatula, 'di ba, ito yung flat end ng ating ano. Ito naman yung scoop eh. Ito yung scoop sa ilalim, sa kabila. Ito yung spatula. Hindi itong teaspoon. 'Di ba? Hindi itong spoon. Okay. So a spatula of salt, place it onto the empty watch glass with the weight of 16 grams. With the spatula and the watch glass, or the watch glass with the content, it weighs 19.4. So what is the weight of your salt? It would be the difference of the watch glass and your salt minus your 16. So your weight of the salt is 3.40 grams. Okay? Next. So, you don't need, kasi may diba, there was a time that you place your empty watch glass without knowing the weight of it and then place the 2 grams of salt. Ay, ma'am, hindi po makukuha kasi po mabigat. Kasi nga, you did not weigh your empty watch glass first before you place your salt. Okay? Next. So, this is your letter C na procedure. This is with precipitation, centrifugation, and decantation. Ano ulit ang precipitation, mga bata? The combination of two liquid substances to form a solid particle. So the solid particle is what we call your precipitate. Okay? Liquid. So this is where we have the process of precipitation. How will we separate? Ang content natin dito is how to separate. We will have to use the techniques and then the separation process. So centrifuge is the instrument. Ito yung device na gagamit natin in order to settle yung ating to separate or to settle the solids and your from liquid. Okay? Decantation is the process of separating liquid from solid. Kumbaga, it will be transferring your liquid to another container. So you only have to transfer and the residue must be left behind here from the original test tube natin. So we will compare the fastest or the slowest, the fastest na process or among the three processes, which is the fastest and the slowest of these three separation techniques. Okay, so we have here the precipitation process. You have your sodium carbonate and your calcium carbonate. Shake until a white opaque substances is formed to your test tube, right? You set this aside until the liquid becomes colorless. Mayroon pang ang tawag ditong clear kayo eh. Ang clear mga bata is adjective. It would be clear blue, clear yellow, clear pink. Pag walang kulay, colorless. Hindi sabi walang kulay, puti. No, white is a color. Tama ba? So you have to be very careful also to watch and the time consumed in order that all of the solids will have to settle here at the bottom. Tama ba? Ito yung tatlong steps na pinagsama sa isang procedure. So, ito yung ating kukunin ang time dito and how long. So ito yung mga 10 minutes sa sinasabi ninyo. Then after that, you have to shake it again and place it into the centrifuge or centrifugation process using the instrument just only for 1 minute. 10 minutes ang ating decantation. And then, yung ang mixing of the two substances, liquid-liquid, is what we call precipitation. Tama bata? Ang ating 1 minute for the centrifuge, observation natin, all of the solids are already settled here at the bottom. Separate na colorless liquid na itong nasa taas. Then, after the centrifugation, you have to decant. Decantate, ito yung liquid that is being transferred to the other container. Ito yon, which is already colorless. And the solid are the substances that is left behind to your original test tube, and that is what we call your residue. Okay? So, anong pinakamabilis? Precipitation. Precipitation is the process of the process of forming the solid particles from liquid-liquid components. How can we separate the solid from liquid? It is done by centrifugation and also by decantation. So ito yung ating simultaneous itong ginagawa. Kumbaga, it will be a coupled reaction para makita natin pag-separate ng liquid from solids. Ang decantate, ito yung ating supernatant liquid. Then for the chemical reactions, ito yung ating pag-balance. We always have to know that in a chemical reaction, we have to follow the 3 laws of combination. Ano nga ba yung 3 laws of combinations? Ito mga batang tandaan nyo, yung mga dinadaldal kong to. Kasi yun ang mga wala sa aking, wala dito sa, hindi ko na-insert yan dito sa PowerPoint. So you have your law of conservation of mass. Conservation of mass. Your law of definite proportion. And then the law of multiple proportion. Okay. Ano ba yung law of conservation of mass? Conservation. Ibig sabihin, maintain constant. And this is done by balancing the equation. The law of definite proportion. This follows the formula at chemical formula. So we'll only have to write the chemical formula correctly if you know the ions. So the ions is the charges ions and your anions. Dapat alam mo yung charges for you to write the molecular or the chemical formula correctly. And the law of definite proportion. So law of multiple proportion, this is applicable for the transition metals. Because the transition metals have more than 1 charges, like that of iron, positive 2 and your positive 3. For tin naman, you have positive 2 and you have your positive 4. Okay? So, I know your teacher also have taught this in the session, in your lecture session, on how would you identify and how would you name those multiple charges ng isang element to form the multiple proportion. So example, ito yung sodium natin by criss-cross process. Sodium, we know it belongs to family 1A. Your carbonate is a polyatomic ion with a charge of negative 2. Always write the positive ion first in a chemical formula to be followed by your cation, your anions. So by criss-cross process, attracted ang positive to negative, making this as N2. The subscript of your sodium is the charge of your cation. And your carbonate, it is a polyatomic ion, acts as 1. The charge of your sodium is 1. So it is written here below. But in writing the chemical formula, we ignore yung subscript of 1. We only have to write it completely as your Na2CO3. So for calcium naman, ang calcium chloride natin belongs ang calcium family to chloride is in 7 family. So it has a charge of negative 1. So it would be Ca1Cl2. So writing your formula would only be CaCl2. That would be the same thing with your sodium chloride, calcium carbonate. So if you can observe mga bata, they're only changing of partners to form the product on the right side of the equation. So our equation natin, you have the reactants and you have the products after the arrow. So the change of partner, okay, mag-change ng partner, attraction would always be with positive and the negative ions. Positive and the negative ions. Okay? Writing them correctly using the charges of each of the ion. Okay, so ito yung double decomposition reaction. Wala pa tayo sa types of chemical reaction, pero kumbaga, nire-review ko na kaya, mini-mention ko na dito, kahit pa paano, mayroon ka ng idea, and I know you have taken that in your senior high. So, for the processes na ginawa natin, ito yung precipitation process, liquid-liquid, and then we'll let it settle down yung solids natin for quite some time. It took 9 minutes for separating the solid to liquid. Then, when we use the device, it is, kumbaga, lesser time was being used in order to settle yung ating solid particles. And this is your centrifuge. Then you have your decantation process in order to separate the liquid from the solid. So what is left behind in your original container is your sediments or the residue. Then the liquid that transferred into the new container is your decantate, or that would be your supernatant liquid. Or it could also be done by filtration, and that I think that is the next process of separating solids from liquids using your filter paper. Okay, ito yung filter paper natin, and the liquid that passes through the filter paper is what you call your filtrate. And the residue are the substances or the solids that are left behind on the filter paper. This is the setup for your simple filtration process. Okay, precipitation, centrifugation, decantation, and you have your filtration. Mga bata, nandyan ha? Okay. Then you have, ito yung ating centrifuge. For 1 minute lang na ginamit. It's kayang-kaya para masettle yung solids. For decantation, it took for a longer time before all of the solids settled at the bottom. The longest time. No? So ang filtration, ito yung we don't have yung conical. Wala tayong Erlenmeyer flask. You can't really have this proper setup sa filtration process. So you have your iron stand, you have your clamp extension, you have the filter paper inside your your glass funnel. Then you have the beaker. If you are to filter more than mga 250 ml, then you can use the beaker. If it is on a very small amount, then you can use yung another setup natin, yung conical lang. Ito lang yun. Ito lang. Pag it's only a few ml, then we can use the simple filtration setup. Pag hindi, pag marami, then ito ang need sa'yo. This is the appropriate for a larger volume. Okay, so this is done by filtration when barium chloride solution and your sodium sulfate solution combine together to form the white precipitate, to separate the precipitate from your solid, from your liquid. This is done by filtration. So the filtrate are the substances, the liquid substances that flows out the filter paper, as I've mentioned. So the chemical reaction, we have it here. So this is sometimes after the chemical formula of barium sulfate, you can see the arrow pointing downwards. So the arrow pointing downwards denotes for the presence of precipitate. Hindi yan PowerPoint, PPT, precipitate. So it's also the changing of partners. This would be your double decomposition reaction. The negative attracts your positive, and the positive with your chloride, barium with your sulfate. Okay, changing of partners. Then another is you have the evaporation. So, di ba nag-pre-weighed tayo kanina ng ating a spatula of your salt. So, we have already the pre-weighed na salt natin, 3.4. So, weigh an empty evaporating dish. Evaporating dish is 31.0. If you have to place yung ating evaporating dish with the content of salt, 34.40. Add 10 ml of water. Diba, ang density ng tubig mo is 1 gram per milliliter. So what would be the volume? 10 ml is the volume. What would be the weight? So density is equal to mass divided by the volume. If you want to compute for the mass, it would be density times the volume. So 1 gram per ml with the 10 ml volume, ml and ml cancels out. So that would also be equal to 10 grams. Diba? Pag marunong ka lang, anak. Pero pag hindi mo ginagamit at nire-relate yan sa theoretical aspect, talagang magkakaroon ka ng error. Okay? Kaya sabi ko nga, kaya ina-assign ko sa inyo ang procedure 1 by 1 or 2 students in a procedure para kahit pa paano, paikutin mo yung utak ba? Minsan, i-analyze mo kung bakit gano'n. Okay? Bakit nga ba 1 gram per ml ang density ng tubig? Okay? So, you have your 44.0 when the three contents are already combined together. Then, you have to heat it, itong evaporation process mo. Your evaporating dish, heat it up until the water totally removes from your solution. So, what is left behind here after heating is your residue. And this is your collected sodium chloride. So, we will have to weigh after it is cooled. When the substance or the container, evaporating dish, and the substance inside is already, the temperature cooled down, that's the time that you have to weigh it again. If, in case, 34.4, then you regained all of your sodium chloride in the process of evaporation. So how would you compute for the percentage yield? So this is equal to the collected amount of salt divided by the weight of sample used multiplied by 100. Ilan ba kaninang collected natin? Ito yon, di ba? After evaporation, 4.0 grams. Ilan ang sample nating na-weigh kanina? Ito yon, 3.4. So 3.40 gram times 100. Gram and gram cancels out. So that is equal to 1 times 100 is equal to 100%. It means that you recovered all the amount of your solute, which is your sodium chloride. So pag yan ay in your computation last time, you only recovered 0.9 gram, divide it by your 2 grams, so multiplied by 100. Kung sa ano to, if that would be in a factory at ganun ang recovery mo, ay talong-talo, luging-lugi ang kumpanya. So you have to, pag ganun ang sa entrepreneurship, you have to think paano natin i-recover at i-regain ulit yung mga ano natin na yan. Pabalikin yung ating capital. Diba? Okay. So, for dilution, hindi pa natin gagawin ito dahil i-apply ko yan sa next experiment natin with regards to solution. Na-skip ko yun, di ba? Okay. Okay. For separation techniques. Ito yan. Kumbaga, na-applyan ko lang ng process of separation. So, if we have this example, mayroon tayong 3 components. You have your sodium chloride, you have your ammonium chloride, and you have your sand. Combined together, you could not identify anymore your ammonium chloride and your sodium chloride because they are of the same white color solids. Siguro, you can identify your sand, but how will you separate the 3 components right now? So when you add water, diba, the 3 steps. You have your ammonium chloride, sodium chloride in this container. So you have to place an inverted glass tubing. Heat it up. Okay, anong magsusublime? So you can see here at the sides or the inner sides of your glass panel. there would be a needle-like substances that stick on the side, and that is your ammonium chloride. Okay? Then, by what is being left behind now in the components is your sodium chloride and your sand. So how can we separate sodium chloride and sand? This time, you have to add water. You have to add water. Andi dito yung water mo for filtration. Add water in order that the sodium chloride will become a solution. Then you filter it. So yung yung residue mo for filtration, this is your resin, yung ating filtrate, ito yung ating sodium chloride solution. Okay, so sodium chloride solution, you have the water and your salt. How can we separate them? By using evaporation process. If all the waters have changes to gas, what is left behind in our container is your salt. So, ayong process ng ating to separate the three components. Ano yung process of separation? Sublimation, filtration, evaporation. Okay. Hindi natin ito nagawa. Okay, yan ay sa iodine. Ito yung isa sa mga proseso din, how to separate the components. It is done by using your separatory funnel, and this is where we call your extraction process. Distillation, ito din yung ating simple distillation in the laboratory. So what are the apparatus? So actually, we did not perform this, but it is embedded into our module na mayroon tayong setup na ganito. This is your adapter. Ito yung the receiving natin for the distillate. Kasi yung liquid that comes from the distilling flask with the mixture, it passes to the condenser. And then, the distillate are the liquid that is converted from gas to liquid. Then you have here your distilling flask, the burner, you have your iron stand, your clamp extension, thermometer, condenser. Take note of the condenser. In order, kasi ang purpose ng condenser is to cool down or to change the gas to liquid. So you have your water inlet and you have your water outlet. So yung water inlet, ito yung nakakonect doon sa faucet. Okay? Then we did not perform this. Chromatography, hindi rin. At enough lang tayo doon. Ano? Okay. So, may tanong ba mga bata? May tanong ba? O wala na. So, continue ako. Wait lang ha. Check ko. So, ilan na tayo? 39. So, dalawa ang absent sa atin. Mga batang may tanong ba? Klaro ba? Klaro ba ang discussions regarding the two experiments? Yes or no? Okay. So, proceed ako. I will proceed to the next experiment at ito yung ating classification of matter. Okay. So, classification of matter, hihinga tayo after this. So, ito yung ating procedure. Napakadali lang naman ito dahil we only have a few substances to identify kung ano yung type ng state niya, kung ano yung change, gano'n. So, ito yung procedure na ginamit. Get a piece of iron fillings and place it, get a pinch of iron fillings and place it on one side of the watch glass which you have partitioned it into quadrants. So place a pinch of sulfur in the second quadrant of the watch glass. Get a pinch of table salt and place it in the third quadrant. And in the fourth quadrant, place a pinch of sand. Observe all the substances on the watch glass and record the observation on the table. So ito yon, di ba mga bata? You have your iron fillings, your sulfur, your salt, and you have your sand. Ito yung kanilang description. So you have the table wherein you can put the description of your substances. Apat ito quadrants. So meron tayong, okay, iron fillings. Bakit nawala ang ating, wait lang ha, may sinut. Okay. Bakit nawala yung write up ko? Wait lang. Mayroon akong ginawa. Hindi siya na-capture. Tingnan ko dito. Ay, ito. Wait lang ha. Wait lang. Nasa structural effects ako. Saan ulit siya? Saan ba na kanina? Ito lang sulat. Gusto ko yung may sulat. Okay. Is it visible on your end? Is it? Sagot, di ko kayo nakikita kung ano yung mga emoticons na pinipindot na. So ito yung ating observations regarding the samples that we had placed in 4 quadrants of your watch glass. So the iron fillings, description, you have the black small metals, and the state it's solid, classification, it is a metal, and then chemical formula is Fe. So ito yung iron mo. So bakit ang chemical formula ng iron ay Fe? Iron. It has no letter E and no letter F in the word iron. It is coming from the Latin name of your ferrum. Okay? For sulfur, you have this as your yellow powder. Ito yung ating yellow powder. It is amorphous. So ito yung amorphous ay it has no luster. Ito yung dull. Wala siyang, when the light strikes on the surface of the sulfur, it did not give off light or luster. So it is your solid. Then, you have your chemical formula of S. For table salt naman, ito yung white crystals natin, crystalline form. It is a solid, and your chemical formula is NaCl2. So your Na, positive 1, Cl, negative 1. What would be the charge of your compound? We know that compound would always have a charge of 0, which is what you call neutral. So let us prove in this. Since the charge of your sodium Na 1 plus Cl negative 1 equals 0. Small letter ito ha. So, positive 1 times 1 atom of sodium plus negative 1 times 1 atom of chlorine equals 0. So, positive 1 plus negative 1 equals 0. So, 0 is equal to 0. Okay? So, charge natin ay ng compound neutral. For sand naman, ang sand na nagamit ko dito ay more on the brownish solid. There are times na mayroon namang gray, di ba? Mayroon namang white. Kaya ang tinatawag nating white sand, yung kagaya ng nasa Boracay. It's, kumbaga, yun yung mga calcium carbonate color. It is in a form of solid. Classification, it would be, pwede din natin i-classify nitong metal, or this would be your element. It would be your element. Tama ba? Table salt as solid in form of compound. Kasi ito yung compound natin which has a constant, definite proportion. It is sand natin, it's also in a form of compound. Hindi ito mixture ha. It would be your compound, SiO2. So, SiO2, okay, negative 2. So, ibig sabihin, what would be the charge of your compound? So, pag SiO2 yan, ang silicon natin, ilan ang charge ng silicon mo? It would be positive 4, right? Plus oxygen, negative 2, with a subscript of 2 equals 0. So, sulfur, silicon, we have the charge of positive 4 with 1 atom times 1. Plus your oxygen, negative 2 ang charge, ang subscript ay 2 equals 0. So, positive 4 plus negative 4 equals 0. 0 equals 0. Okay, so na-prove ko yan mga bata ha. Bakit? Bakit ko ito ngayon na-prove? Kasi magko-compute ka ng percent composition. And I know si Sir siguro nakuha din naman ninyo ngayon ng mga composition na yan. Okay? So, ito yung ating paper. Ano pinanggagalingan ng papel? Ito yung several trunks of trees. Tama ba? Pinuputol ng ilang punong kahoy ng ating punong kahoy para makapagawa ng papel. So, we have your bond paper. Ito ay yung malinis na papel. Ito yung puti na papel na kinuha ko. Last heat. You put it over the flame. Makikita natin, unti-unting nasusunog. Unti-unting nasusunog ang papel dahil ang organic compound are flammable. Okay? So, ito yung isa sa mga properties ng organic compound. Flammability. So, yung ating white bond paper naging gray ash. Bakit? Dahil ito ang color ng carbon. Dahil ang organic compounds, the main constituent is carbon atom. Kaya lahat ng kahoy, ang charcoal itim. Diba? Pag ang damit natin nasunog, itim ang kulay. Dahil nagre-represent ng carbon atom present in the organic compounds. Anong kulay ng apoy ang nakikita mo? Yellow flame. And this is your luminous flame. Okay? Kaya mayroon tayong napag-aralan regarding sa type ng at color ng apoy na binibigay ng Bunsen burner. We have done it before. So, anong type ng chains ito? Yung property ng ating reactant or the sample did not retain after heat application. So, it is your chemical property, chemical change. There is a new composition of the products. The next is you have the sugar. So, yung sugar natin, ay naghahanap tayo ng metal cap. Diba? Ito yung tansan na ginagamit natin pantakip ng mga soft drinks. Kaya lang, soft drinks kasi natin bottle ngayon is plastic bottle ang medyo common. Kaya wala tayong yung tansan. Kaya I told you to use the small test tube para pag dumikit man at hindi matanggal, we can replace it at a small amount lang. 20 pesos yata ang isa nito, no? So, ito yung characteristic ng sugar natin, crystalline. Okay? So, when we place it into the test tube and apply heat, ito yung magiging color. From white, pardon? Can you see what I am projecting now? Is it visible on your end? May naririnig ako. Is it visible? Yes or no?
Yes po.
Okay, okay. So, mute your microphone please. Naririnig ko kasi yung conversation. So, you have from white color nating sugar. When heat is applied, ito yung nangyayari. It gradually changes its color from light brown to brown color or it will be to black color. Pag brown color, ito yung pag-melting. It is the melting reaction or process ng sugar to liquid. So, solid to liquid. For further application of energy or heat, that's the time na nagiging black ang color ng ating carbon or ng ating sugar because ang sugar contains carbon. Now, as the sugar melts or melted, this is where we can also smell the caramel odor. So, ibig sabihin, andito yung sweetness na yung sweetened or sweet or your sweety odor ng ating sugar na naaamoy mo. Okay, and that's the time, the start of the composition of your sugar into carbon and your water. Kasi mga bata, ang general formula ng saccharides or sugar, C sub N, HO2N. Okay, so ito yung general structure ng saccharides. Kaya pag ano natin siya, pag yan ay decomposes by the application of energy, it will decompose into carbon and your water molecules. Okay? What type of change? Chemical change. Bakit chemical change? The property of the product is not the same as have the identity before it was heated. Okay? The next is you have your 6 molar HCl and your magnesium ribbon. Ang magnesium ribbon na binigay ko sa iyo ay hindi color na gray. Itong parang gray color. It's not, it's a metal. It is coated ang binigay ko. But when we scrape off yung color na black dito sa labas na, ito yung makikita natin. Ito din yun. Okay? So you have your test tube. You place 1 ml of your 6 molar HCl and drop a 1 centimeter cut into 4 pieces. 1 centimeter of your magnesium ribbon. But you are asked to cut it into 4 pieces. Bakit? In order, but kasi ganitong konsepto doon, the greater the surface area that is observed in your solution, the faster it will dissolve. Kasi pag malaki nga naman, mahaba na 1 centimeter na isahan lang ang ilalagay mo doon in your 6 molar HCl, it will take a longer time. Whereas, pag 4 pieces yan, maraming maliliit na naka-expose. Ando doon sa solution mo, surface area itong pinag-uusapan. The faster it dissolves. Okay? So, you have to fill the side of the test tube. And then you have to record your observation. So, while it is changing or while the chemical change occurs, nakikita mo there is the formation of bubbles. And the bubbles determine for the release of hydrogen. Okay, so ibig sabihin, there is a chemical reaction that takes place, that had taken place. So you have your magnesium with your HCl. Paano natin ipakita? How will we can relate it with the chemical reaction involved? This is where we have, it is your single replacement if you can remember in your types of chemical reaction that you have studied in your lecture. That the more electronegative element can displace the less electronegative element. So we know that magnesium is stronger than that of your hydrogen. So definitely magnesium can replace hydrogen, making it into MgCl. To write the chemical formula, you have to remember the charges of your magnesium. Your magnesium belongs to family 2. Your chloride belongs to 7. So this would be MgCl2 by Crispus process. And since magnesium replaces the hydrogen, what happened to the hydrogen? It makes it a free element or free compound because hydrogen in a chemical reaction would always be diatomic. Hindi siya nagre-represent lang na big letter H because big letter H is a symbol of an element for hydrogen. In a chemical reaction, it would always be H2. So this is where you have to apply the combination, the laws of combination. So you have your conservation of mass. You have to balance the number of atoms on the right and on the left side of the equation by looking for your coefficient. So your coefficient is the number that you have to write it before the chemical formula. It must not be inserted in between the chemical formula. This is wrong. It must be before or in front of the chemical formula. So you have your 2 moles of hydrochloric acid, 1 mole of your magnesium ribbon can produce 1 mole of your magnesium chloride and 1 mole of your hydrogen gas. So you have the hydrogen gas here, you have the arrow up. This is the arrow up here means that the substance releases gas. So the bubbles is the one that determines or that tells us that the gas is evolving to the atmosphere or to the surroundings. So this is hydrogen arrow up. Okay. So this is your chemical reaction to form new products undergoing chemical changes. Anong nagbago? Magnesium ribbon mo. Ano nanggaling what happened to the magnesium ribbon? Dissolve to form now your solution, magnesium chloride and the hydrogen. So the last test tube that you have observed was with your ammonium chloride in water. So ammonium chloride is a solid, more of as very, very small crystals. So this is dropped into your test tube again, ito yan, with your water. So upon adding your ammonium chloride and H4Cl into the solution, when you feel it here at the sides of the test tube, it is cold. So it means that there is a release of, kumbaga, energy while the process is going on. So ito yung procedure. In another test tube, place 3 ml of your distilled water and add a pinch of ammonium chloride. Then fill the side of the test tube. Itong in-ignore nyo eh. You did not, kumbaga, follow the procedure. Record your observations. So in this presentation I have, you have here the initial temperature. Before the initial temperature of your water before the ammonium chloride was added into, it is at 20 degrees. Okay? When ammonium chloride is added into the solution, here is the flow of the temperature. It is decreasing. It means it releases energy, no, to the reaction at the reaction. But when we fill the sides of the container, what will happen to the energy? Kasi ito is susceptible to accept energy from the surroundings. And this is what you call accepting energy to the system. Ang system ang nagbigay, di ba? System, ibig sabihin yung solution natin or the reactants and the products that is occurring here inside our test tube. So we can see that there is a decrease of temperature when your ammonium chloride combined with water. And this is your endothermic reaction. Why endo? Because it can absorb energy, diba, to the system. So you have here a piece of, ito yung ating result. Hindi ko nabalik. Okay? So yan na yan, mga bata. So yan ang ating two experiments, classification, changes, and we have now the tatlo ng nabigay techniques. We have the techniques. The last experiment that we have to discuss is about or to share regarding the result ay yung ating types of chemical reaction. Okay. Sa mga bata, I know na nakikita nyo na ngayon yung results ng iyong output regarding the three experiments. May tanong ba? May mga tanong ba kayo? May tanong ba? Lahat ba mayroong score except siyempre yung mga absent. Hindi po pwedeng bigyan ng score ang absent eh. Paki-check naman mga bata para kahit papano kasi I will honor only yung mga checking ng ating wait lang yung mga results natin ay with your scores it must be done before the exam. Pag after the exam at hindi ka nag-react, ibig sabihin lahat na na-encode kong scores mo ay tama. Okay? So, I will give you 20 minutes break. So, ngayon ay 8:36. So, plus 20 minutes, bibalik kayo sa akin 8:56. Action. Is it visible on your end? The PowerPoint that I am projecting, is it visible on your end? Yes or no? Yes? Is it visible? Ay, hindi. Hindi kayo sumasagot. Oo kayo ng oo. Eh, sa akin yan, hindi ko nakikita. Okay. Thumbs down kayo. Okay, ganito. Change ako ng ink. Change ako ng ink. Okay, here. This would be pertaining to the last experiment in this midterm scope, types of chemical reactions. So the objectives of this experiment is for you to be able to distinguish among the different types of chemical reactions. Also to identify the reactants and products of chemical reactions and to develop skill in writing and balancing equations. Yun ang purpose. So we have here the definition of terms like that of chemical reaction is the process of combination of the starting materials to form products. And other symbols to illustrate what reactants constitute, the starting materials in the reaction, and what products are formed. So we have this an example. You have the symbol of plus. So meaning this would be a place between substances. So example, you have your methane plus your oxygen. Okay, to form carbon dioxide in water. So you have your expression of the reactants, the substances after the arrow are your products. So you can see the symbol of plus in between the substances. In between the substances. Then you have the arrow. This means it yields or to produce the location between the reactants and the products. And your symbol for S enclosed in parentheses, it means that the substance is a solid and this is written after the chemical formula like this, or your KClS, or your K12H22O11S. It is enclosed in parentheses. It means that the substance is in a form of solid. L, This is enclosed in small letter L in a parenthesis, determining that the substance is a liquid. It is written after the formula. So example, your water L, or this would be with a subscript of G. Okay, enclosed in parenthesis ang small letter L, enclosed in parenthesis ang small letter G. Because letter G is also a symbol that the substance has the characteristic of a gas. AQ, that would be the aqueous solution. So you have your NaClAq. So you have your sodium solid, okay, plus your liquid water combined together to form an aqueous solution. So aqueous solution always referring for a solvent water. Okay, your delta. So delta, this would be the representation of heat and it is written above the arrow. HV, this would be your light energy, or also written above the arrow. Arrow up, that would be for a gas formation, it is written after the formula. Because your hydrogen gas with an arrow above it. Then you have the symbols also in a chemical reaction as of this R, the arrow towards the right, you have the arrow down for precipitate. Last, for added reversible reaction, you have the double arrow towards the right and to the left. You have the delta, that's the impression wherein the addition of energy to the system or to the reaction. Arrow up is the formation of the gas. Subscripts of S, L, G, and AQ are the status or the states of the substances. So the types of chemical reactions, these are your combination, decomposition, single replacement, and double replacement. Sometimes combination is also known as synthesis. Decomposition, this would be your hydrolysis. Or sometimes the splitting. Simple displacement, also known as your simple replacement. Simple decomposition, or double decomposition, or double displacement, or double replacement. DD or DR, or that would be double displacement. So it would be the synonyms of these types of chemical reaction. These are what considered the simple chemical reaction. Okay. So there is a special type of chemical reaction, and I know you discussed this in your lecture. So this is your redox reaction. The redox or reduction oxidation reaction. Did you discuss it in the lecture about the redox? Bigyan naman ako ng output. Bigyan naman ako ng sagot. Did you discuss redox in the lecture? O wala akong estudyante? Mga bata, na-discuss nyo ba ang redox?
Not yet pa po.
Sagot. Ang layo. Na-discuss ba yung redox, Mr. Pagal?
Hindi po, Doc.
Ano lang na na-discuss ninyo? Simple chemical reactions lang? Ito lang bang 4? Na-discuss nyo ba to? Hindi.
Hindi pa
Iba
po,
po.
Doc.
So, anong topic na kayo sa lecture? Anong module na kayo? Suntok sa buwan na. Bakit tinawag itong simple reactions mga bata? Itong 4 na to.
Chemical,
Ano yon?
chemical bonding po.
Chemical bonding pa lang kayo. So, ibig sabihin, right after the periodic table, Yun ang unang-unang module after ng prelim. Kasi hanggang dapat kayo sa periodic table, tama ba? How atoms combine, nandito na yun sa midterm. Yun ang chemical bonding. Pagtapos ng chemical bonding, writing and naming of compounds. Pagkatapos ng writing and naming, types of chemical reactions. So, anong hindi nyo nakuha ngayong midterm? Twice a week ba ang klase nyo? Sa lecture? Nakalimutan nyo na yata yung
Yes
schedule mo.
po, Doc.
Okay. Twice a week, so that would be 1 hour every meeting. Okay. Please lend me your ears and your eyes. If this would be your first eyes. So, these 4 types of chemical reaction, tinawag siyang simple reactions. Bakit tinawag siya ng simple reaction? These are the chemical reactions that could be balanced only by trial and error method or what we call by inspection process. Okay, pero ang redox reaction, hindi mo ito mababalance ng inspection or trial and error method because this other reaction, tinatawag siyang complicated dahil 2 reactants can produce 3 or 4 products. And this is, ang balancing could be done by the loss and gain of electrons. Kaya you have the redox, this would be the gaining of electrons. And your oxidation is the losing of electrons. So this is what we call your coupled reaction ng redox. Ang redox reaction, you have to identify and to write the oxidation numbers of the elements above it in order to inspect which of those elements has the change in oxidation number. Okay? Yun ang purpose. So the combination reaction or what we call the synthesis, ito yung 2 reactants combined to form 1 product. So tama lang palang pag-prepare ko ngayon ng aking discussion kasi nasa lecture ko to. Itong the first few slides ay sa lecture topic ko to. Ito ang ginagamit ko for chemical reaction discussion. Pero pag nasa laboratory, hindi ko to dinadala. But for in your case, kasi tama rin lang pala na hindi nyo na-discuss to kaya tama yung pagtastada ko ng PowerPoint. 2 reactants combine to form 1 product. So this is what I have here in this PowerPoint to show the hypothetical. Anong ibig sabihin hypothetical? I am not referring directly to the substances, but rather it is represented by other symbols. So like that of A plus B to combine together to form AB. But have to remember mga bata, ang ions are of different ions. Positive and negative has the tendency to combine. But with the same type of ions, positive with positive, there would always be repelling actions. So as that with negative and negative. Okay? Then we have the decomposition reactions. The decomposition reaction is the splitting of the compound into 2 or 3 products. So this is where we have a single substance breaks down to give 2 or more different substances. Of course, they don't maintain its identity of the reactant. So hypothetically, so you have here 1 or a single substance breaks down. So positive, negative, with the reaction of energy gives 2 or more different substances. So this would be your A plus B. Okay? It will split ang A and B. But one important rule here is with the application of energy. Often, mostly of the substances undergo decomposition with the application of heat. Single displacement, reactions that napaka-importante. This is with the replacement of the lower electronegativity element against that with the higher electronegativity elements. So one element reacts with a compound to replace one of the elements of that compound. So ito yun. Example, one element reacts. So this is example, this would be the positive ion. In a compound, you always have to write the positive ion first to be followed by the negative ion. It must not be interchanged. That would be maintained. So if the electronegativity or the strength of element A is greater than that of element B in the compound, A can replace B to form a compound of AC and making B as a free element. Ito na siya. Okay? So, free element. So, single replacement is like that of a boyfriend-girlfriend relationship. Example, you have your boyfriend or girlfriend in your high school. Now that you are in college, you are not of the same school anymore. So, medyo, you are not in your company daily. So, you have now your distance relationship. Now, at this 10 weeks or 11 weeks that you've been in the university, there is an individual that catches your attention. Ang siste. You have here the standard. Will you maintain or be with your boyfriend in high school or to accept the new individual that is coming into your way? So that depends. Companionship daily, there must be always a change. Example, you have been admiring or attracted to the new individual in the university. So definitely, higher qualities ang A. That's the time that it could replace your former boyfriend. So making it now a new bond to a new person with AC plus free. Let the former boyfriend be free. And this would be your B. So AC plus B. Okay? So your A replaces B to make it AC and plus B. The fourth type of chemical reaction is double displacement reaction. So ito yung exchanging partners, but this could not be applied in real life. So the two compounds na ginagamit ko dito. Because this would be the metals containing substances that has two transfer electrons to the nonmetals. Okay? Transferring of the electrons. And the bond between the atoms here in this compound is what we call your ionic bond. Okay? So, this is the exchange of partner. It must not be with the same charges ang magiging atoms natin. It must be positive and negative. And the positive or the cation or the cations would be written ahead of your anion. So there are, in our book, we have there the tables of cations or the anion and the anions, the list of the atoms with the negative and the positive charges. If you know, if you have bought your book or you have purchased your book, then you can find it there. Chapter 9. Ando doon yun. Okay? Chapter 3. 3 and 4. Okay. Chapter 9 kasi acidity and basicity. Okay? Kasi yan ang mga topics na dapat nung kinuha regarding sa types of reactions. You have acidity and basicity. You have the redox reaction. So sa acidity and basicity, you have the computation of the pH. Okay? So you have your positive and negative charges. Definitely, ang mag-change ng partners, yung A mo o combine with D. Okay? So to form now, your AD, so your A displaces the C and combines with D to form your AD, and what is left behind now are your B and C. Tama ba? B negative and your C positive. So it could not be BC. It must be the other way around. It would be CB because your C here is positive and your B is negative. Okay? Then for the types of chemical reactions, we have your direct combination or synthesis. So decomposition, or this would be hydrolysis. The single replacement would be your single displacement or single decomposition. And your double replacement, double displacement, or double decomposition. So we have your hypothetical representation of, you have your water. To form water molecules, you have your 2 moles of hydrogen. Ito lang yan. Hydrogen and your oxygen. So the numbers that are written here in front or before the chemical formula is what we call your coefficient. So hydrogen and oxygen is always diatomic in chemical reaction. It must not be O and H only, because H is the representation for hydrogen element, O is the representation for the oxygen element. In a chemical reaction, there would always be diatomic. So you can find out why there is a double bond, a single bond between hydrogen, and that is with the sharing and the overlapping of the atomic orbitals. Okay? So you have it as, to balance the equation, there are 2 moles of hydrogen react with 1 mole of your oxygen to form 2 moles of water. Okay? With your magnesium ribbon, ito yung ating magnesium ribbon na light, na hit mo or na ignite mo, plus the why it ignited because of the oxygen present in the surroundings to form now the product of magnesium oxide. Okay. So remember, always in balancing a chemical equation, you have to remember the laws of chemical combination. And these are the laws of conservation of mass, the law of definite proportion, and the law of multiple proportion. So na-mention ko na yun kanina, di ba? So yung ating law of conservation of mass is the balancing of the number of atoms on the right and the left side of the equation. For the law of definite proportion, in water, we always have a constant proportion of hydrogen with oxygen. This is 2:1. Hindi pwedeng magbago. Pag mag-H2O2 yan, hindi yan tubig. It is yung agua oxinada. So the ratio here is 2:2. It is not water. Constant palagi ang water. Then, with your magnesium oxide, we have here the law of multiple proportion. So this is applicable to the transition metals. Like when your iron reacts with oxygen, kaya mga bakal na walang pintura, bakit di pinipinturahan ang bakal na naka-expose minsan sa mga construction area? Dahil ang bakal, when it is exposed to the atmosphere, it could react with the oxygen to form the rust. So if you have your F2, it will form the rust of FO. Kasi ang oxygen at saka yung iron natin would have the same oxidation number, F2O2. So by criss-cross process, it will become FeO. In Fe plus 3, the product in a form of rust will be your Fe2O3. So your oxygen is -2, ang oxidation number, ang iron is +3. Criss-cross process, there would be exchange of ating charges in terms of subscripts. Dahil ang positive will react with negative. The composition reaction, hypothetical representation, what if we have your calcium carbonate? AB, it's the compound. With the addition of energy, it can form A plus B. Will split into A and B. So would it be possible na ating calcium carbonate? Is it possible that by breaking of the bond would only be equal to your Ca plus CO3? No. Why? Because CO3 is not a compound. It is your it is with your polyatomic ion. Because carbon has a port charge of 4, oxygen is negative 2. So by criss-cross process, it would be C2O4. The subscripts of carbon and oxygen are divisible by 2. So this would be CO2, carbon dioxide. Okay. So what would be the product? This is the exact and the correct must be with CaO plus CO2. So your CO2 plus your calcium oxide. Calcium is positive 2, oxygen is negative 2. Criss-cross process. CO is your chemical formula for calcium oxide. Okay. Another example is your copper sulfate, the one that I've already used in changes of matter. When heat is applied into it, there would be a formation of A plus B. What is that A? That is your copper sulfate and your water. Since it is a crystal, there would be 5 moles of water. So if you heat the substances, your copper here, or blue, changes into white, and the droplets of water are deposited there or stick on the sides of the upper portion of your test tube. Okay? It means that there is the decomposition process. The single replacement, you have your A plus BC equals AC plus B. So example, you have your magnesium ribbon, you have your HCl. So magnesium ribbon plus your HCl. Magnesium is more reactive than that of hydrogen to form your magnesium chloride, Cl2 plus free of hydrogen. Hydrogen is diatomic. Why Cl2? Magnesium is positive 2, your chloride is negative. So criss-cross process. And that would be the same thing with iron. When placed in HCl, your iron can displace hydrogen to make it at FeCl2 and your free hydrogen gas. So for gases, to remind everyone, this would also be represented by an arrow after hydrogen gas. It means that would be a release of bubbles or gas to the atmosphere. Then for double replacement, ito yung hypothetical representation, AD plus CD equals AD plus CD. So if we have here your liquid of your potassium nitrate, your lead nitrate with your potassium sulfate, changing of partners, this would always be the negative. Ito yung positive mo, right? Ito yung positive 2. Ito yung positive 1, polyatomic ion with a charge of negative 2. So positive lead will combine with sulfate to form your lead sulfate. Arrow down, it means this is the precipitate. So your potassium ion to comport again with your potassium nitrate. Plus 1, negative 1. So KNO3. With potassium sulfate and barium chloride, exchange of partner will form your KCl. And your barium sulfate, it's also your precipitate. So the arrow down is representing a sign for precipitate. Okay, so you can balance the equation by just inspection process. So you always have to look at the substrate and the left side of the equation is 2. So you make this as your coefficient on the right side. Okay? So magbabalance sa yung equation. That would be your hint. But for a redox reaction, you have to see what are those elements that changes in charges. And that's the time that you have to connect it with the bridge. Okay? So we have here the procedure to work on regarding our activity. Ang ating nilagay 8 plus B. Because in our manual, ando doon yung procedure that observation on the reaction of sulfur and magnesium with heat, water, and litmus paper. Rewrite the observation in the table, it means that it was already been performed experiment. Ito yung ating sulfur. If you can remember, yung sulfur watch, yan. Ito yun. Draw. Okay. So you have your sulfur. You place it in a, saan natin nilagay? Sa what? Glass tubing. So one end of the glass tubing, ito yung powder natin, sulfur. We heat up and then the fumes are then trapped in here at the other end. Parang walang contamination. Kasi once your sulfur is melted, it will drip into your test tube. To avoid such scenario, we have to collect the fumes at one end of our glass tubing. But the rest, sometimes yung mga ginagawa ng iba, hindi tama, di ba? Kaya I demonstrated it to you before on how to perform it well in order to get the correct answer, the correct procedure, and the correct product. So when hindi ko masulatan to. Kalimutan ako ng okay. So, ito kasi yung sulfur natin. So, dito yung sulfur powder. We apply heat into here. Then, we trap. Dito yung test tube mo. Actually, dapat naka-U-shape yan. Since ang binigay sa atin ay on the straight, so dito yung fumes. And then yung fumes, you have to trap it with a stopper. Dapat yung fumes dito na, so change it in a vertical position, then may stopper ka dito para yung fumes hindi lalabas. So that's the time that you have to add 1 ml of distilled water. Then you mix that, diba? You mix the solution, and this is the time that you have to open your stopper and place here your litmus paper. So, anong nilagay natin litmus paper dito? The blue litmus paper. So, what was the change of your blue litmus paper when it reacted into your solution? So, it becomes red. So, it means that the substance formed in your test tube is an acid. Okay, recall natin. Sulfur, yung sulfur mo, you have the application of heat. So why there is a production of heat? Due to the reaction of the oxygen gas in the atmosphere. So when it forms, when it reacts with your sulfur and your oxygen, it will form your sulfur dioxide. Okay, gas. So yung sulfur dioxide gas had added with your water. Continuous reaction itong ginagawa ko. So ito ngayon, it will become your H2SO3. Okay? Tama ba? Okay. SO3. So, ibig sabihin, ito yung hydrogen sulfide. So, hydrogen sulfide is a form of acid. Tama ba ang test natin? Okay. If you did it correctly, then there would be a change of litmus paper from blue to red. It means that a product formed with the fumes mong nakulit, ito yung ating white fumes that has been trapped inside your test tube. Add it with your water, shake, and add with your litmus paper blue. it changes into red, meaning that the solution that is being formed inside your test tube is an aqueous solution of your hydrogen sulfide. Okay? Sundan. The other is with your magnesium ribbon. Ito yung ignite. Directly your magnesium ribbon. Ignition. So this is where you have the formation of ash. Gray ash. Okay? You place it in your evaporating dish. Plus water. Okay? So this is where we have now yung gray ash. Anong magiging actually, hindi to na continue heating lang sa inyo. Up to heating lang kayo. So you have it could be tested by an indicator. Indicator. Ito yung mga substances that could determine if it be acid or base ang ating mga solutions. So indicator like that of phenolphthalein. Phenolphthalein is an indicator pag ang color with your ash and the water added into becomes pink. So, ibig sabihin, it is a basic substance. Pag ang phenolphthalein added into the solution at becomes colorless ang solution, it is acidic. Try natin sa magnesium ribbon. Magnesium ribbon, tingnan mabuti itong reaction plus ignition, the oxygen coming from the source. So this is where we have your magnesium oxide. So magnesium oxide is your ash. Okay? So it means there is already a chemical change. Adding plus your water, it will form magnesium hydroxide. Okay. So your magnesium, your water kasi, pakita natin yung ions. Hydrogen, hydroxyl. Okay. Tama ba mga bata? So you have your magnesium hydroxide. So your magnesium belongs to family 2 with 2 unpaired electrons. Right mga bata? So if this would be giving up of electrons to a polyatomic ions ng hydroxyl. So this is where we have your OH bond. Ito yung hydrogen mo. OH bond. Ay, hydrogen. So dalawang hydroxyl group attached to your magnesium. Then, definitely, mayroon kang hydrogen gas. Okay? Nang nilagyan mo ng litmus paper, last, litmus paper. Anong litmus paper ang nilagay mo dito? Blue. Changes to red. It means basic ang substance mo. Kaya pag phenolphthalein, basic din kasi it gives a pink colored solution. Sa litmus paper, blue changes to red. It means acid. Okay? So yan ang ating example ng combination. Magnesium plus oxygen, A plus B combined together to form AB. Sulfur plus A plus B combined together into 1 SO2. Okay? Okay. So, I will discuss later yung nitric acid with the copper wire because we did not perform this. But this is one among all the examples also on how will we combine your nitric acid with your copper wire. Okay, so ito may combination din tayo. A plus B, but it will produce other substances. So next is you have there your ito yung reaction kanina ng sulfur to form your sulfur your hydrogen sulfide or your sulfurous acid. Hydrogen sulfide, or commonly known as your sulfurous acid. Aqueous, may additional ka ng tubig. So the result, ito yung ating magnesium ribbon, lighted magnesium ribbon to form your magnesium oxide. So by balancing an equation, dapat number of atoms on the right and on the left side of the equation pareho. So you have to find for the coefficient that is written before the chemical formula. So when water is added in 2, it will form your magnesium hydroxide. Okay? Walang hydrogen. Wait. Bakit mo? Wait lang. Babalikan ko yun ha. Walang hydrogen. Wala ito. Wala siyang bubbles. So your magnesium hydroxide. Oh. Walang liberation of gas kasi hindi naman siya acid. So, for the magnesium oxide, ito yung ash mo na dinagdagan ng tubig, it form your magnesium hydroxide. For the litmus paper indicator, your blue changes to red. Hindi po. Your blue remains blue. Your blue changes to red. It's a basic. But the, yung red, hindi, yung blue remains blue. Blue, tama ba? Tama ba mga bata? Blue remains blue. Red changes to blue. For example, another example ito. We did not perform this in the lab, but I'll give this example when calcium oxide is added with water. This is where we have the combination of calcium oxide and your water to form calcium hydroxide. So calcium hydroxide is your lime water. Ito yung lime water na tinatawag. Ito yon. Calcium hydroxide, ang ating systematic way of naming. Ang ating common name ay lime water. With your phenolphthalein, it gives a pink-colored solution. So, ibig sabihin basic. No? Pag yan ay blue litmus paper, it will change into, it will remain blue. But the red will change into blue. Ibig sabihin basic. So, ano magiging conclusion mo dito? Ano magiging conclusion mo dito mga bata sa slide na to? What have you observed? Basic. So, anong ibig sabihin? Metal oxides. The metal oxides are basic substances. Tandaan mo yan. Okay. So, for the magnesium ribbon, ito yung napakita ko na kanina, yung chemical reactions mo with your magnesium plus the oxygen to form your magnesium oxide. So, to balance the equation, you need to write a coefficient. So, the magnesium oxide is added upon with water to form your magnesium hydroxide. Okay. So, this will be your basic substance. So, the change is red to blue litmus paper. Ibig sabihin base. Pag phenolphthalein, that would also be pink-colored solution. Okay. So, the reactions of active metals with water. Ito yung ating sodium potassium. We will not perform this in the lab because it is very dangerous. Pag sinabi mong very reactive, pag yan in-attach with a small amount of water, it will explode right away. So we will not do it in the laboratory because it could cause mawawala yung ating lab. If there will be, all of you will have to try with sodium and potassium reaction with water. It will form here. There would be an explosion. Kaya we only do this, the balancing equation and the reaction would only be shown to you based on the theoretical aspect. It's yung aspeto lang ng theory that sodium when added with water, it will form your sodium hydroxide and the hydrogen gas. It's explosive, tama ba? Then your potassium and water can form your potassium hydroxide and or your hydrogen gas. So ito kanina, walang hydrogen gas ang magnesium hydroxide. Wala na napo-form. It's only magnesium hydroxide. Okay? So, o pwede ding matest ang ating magnesium hydroxide without ignition. Hindi siya ini-ignite. We only have to boil it with water, together with water. Itong ating magnesium ribbon. And it was been tested that it could form again magnesium hydroxide. Hindi ito yung ignition na boiling lang, boiling of magnesium ribbon. Still, it is a basic substance ang mapoform niya. So, ito yung ating single replacement process that we need the reactivity of the metals and to show what is the most reactive element in the periodic table. Actually, it is rubidium, but it was not been shown in here. But we only have the first family. Family A, you have potassium. All of the elements that are under potassium, it could be displaced by potassium. With calcium, all of the elements under it could be also displaced. Sodium, all the elements under sodium could be displaced by sodium. Pwedeng palitan ng sodium. So example, your sodium with your hydrogen hydroxyl. So positive ion ng sodium, positive ion din ng hydrogen. When we count of its reactivity, sodium from the top, that will be the third element. Hydrogen, 4, 5, 6, 7, 8, 9, 10, 11. It is at the number 11. So when we account of its reactivity, sodium is reactive than that of your hydrogen. So sodium can replace hydrogen to make it sodium hydroxide and hydrogen gas. But are very reactive that it's not advisable for us to do it in the laboratory. Do not test it, please. Okay? With our properties, with the carbonates, ito yung sodium carbonate belongs to family 1A. Your calcium carbonate belongs to family 2A. So, when we have to heat it, ito yung carbonates na pinagawa ko sa inyo. No? Calcium carbonate lang yata ginawa natin. Before heating, it is also in a form of liquid. But after heating, we have seen that with the application of it, the more that the moisture is being removed, the more na nagiging intact kumbaga yung substances. Kaya more na nagiging dry siya. Okay, it results dryness. So your sodium carbonate, when acted upon by heat, it will decompose into your sodium oxide and carbon dioxide. Okay? Then for calcium carbonate, with the reaction of energy, it can form your calcium oxide and your carbon dioxide. So balance equation, inspection. Oxygen is 3 on the right, oxygen is 3 on the left. Carbon is 1 on the right, carbon is 1 also on the left. Sodium is 2 on the right side, on the left side. So you need your coefficient dito sa sodium mo. No? So you have to try to balance the equation. Your calcium, this would be your positive. 1 mole of calcium carbonate. And this can produce 1 mole of calcium oxide and 1 mole of carbon dioxide. Okay, 4, 2. So if that would be the case, it would not be balanced if you only have to write the 2 here with the sodium hydroxide. Your oxygen is 4 on the right and on the left. That would be, let's try to have the 2. So 4 ito, then 6 ang ating oxygen. Okay, 4, carbon mo is 2. Bakit ayaw? Wait. Then for sodium carbonate, potassium carbonate. So these are the descriptions. Kumbaga. So when we have to add it with water, itong ating family 1 carbonates and family 2 carbonates, The family 1 carbonates are soluble in water. The family 2 carbonates are slightly or insoluble in water. Slightly soluble lang sila. Then for the sublimation, this would be your copper sulfate pentahydrate. When you heat it, it will form copper sulfate and 5 moles of water. So this is what we have done. Now we can observe that the blue colored crystals here changes into gray or white. It means that the water in the blue crystal separated crystals with always a hydrated substances yon. So we have here the water that is deposited here at the upper portion of our test tube. Wait lang mga bata, sandali lang ha. Dali lang.
Paano lang kayo, no? Hindi mo kasagot. Takbo ka pa kasi. Tingnan natin. Ito po, malakas.
Okay. Wait lang. So this is not the process of decomposition. Wait lang mga bata. Wait. Ay.
Oximeter po. Ay, ito.
Okay. Saan ako? Check natin yan. Wait lang ha. Check natin itong reaction. Wait lang. Ay, mali. Kasi ito ay NaO2. Okay, hindi natin. Okay. So your sodium is positive 1. Kumahan ako sa sarili ko. Positive 1. Oxygen is negative 2. So this your Na2O. So ilan ang carbon dioxide mo? Isa. Oxygen is 3. So tama na. No need to balance the equation. Ito na yan. Nabuduling ako pag ganitong hindi na ba. So you have it as bakit? Iba kulay. Iba kulay ko. So your N2O plus CO2. 1, 2, 3. Low. Carbon isa. Sodium 2. Okay, balance ang equation natin. Okay, klaro na. 955. Okay, wait lang. So, for our single replacement, nakuha na natin. Ito yung single replacement. Okay. So, you have there your staple wire. So, your staple wire in copper sulfate, there would be formation of rust. So, your iron can replace your copper sulfate. Kasi yung iron mo is on place of 7, yung copper mo is 12. So, reactive ang iron than that of copper to form your ferrous sulfate and the copper elements. Next is you have the reaction of HCl with your magnesium ribbon. So, with regards to the property and reactivity activity of magnesium, it is at number 4. Ang hydrogen is number 11. So definitely magnesium can replace your hydrogen. So for magnesium chloride, and you have your hydrogen gas. Hydrochloric acid with your copper. Take note. Hydrogen is 11, copper is in 12. So copper could not replace hydrogen. So there is no reaction. Still, ang copper mo ay shiny pa rin. It is untarnished ang atin. Anong una nga natin?
May sinto.
Anong una natin na reaction? Hindi ko maalala. Tama ba? At ferrous sulfate plus the copper. So your copper is in 12. Your copper could not replace the iron. So it is no reaction. Okay. So that's the end ng ating third experiment. The third experiment that we perform na nandoon sa ating experiment. So if ever, pag may tanong, pwede namang okay. Magtanong siyempre sa akin. White lang po. Ano yun? Ano yun, Miss Garcia? Ano yun, Miss Garcia? Please unmute your microphone. 37. Okay. So may tanong ba mga bata? Yes, Trestiza. Unmute your microphone, Miss Trestiza.
Hello, miss. Nalilito po kasi ako kanina nung
Hindi kita
nagpa-attendance po
maintindihan,
kayo.
anak. Layo mo. Layo.
Na-late lang po ako kanina nung nagpa-attendance po kayo.
Bakit you are using the account of Pagal?
Hindi po kasi gumagana yung mic ko po.
Where are you now? Are you in the school? Nasa school ba kayo?
Yes po. Opo.
Do you have, may class ba kayo after me? On-site?
Meron po. May exam po kami.
May exam kayo for today. Okay, sige. So, ano yun? Prestiza.
Opo, miss.
Okay. Si Gomez,
Sige
nandyan
po.
ba? Thank you. Sige. Anong oras ang klase niyo? Anong oras ang exam niyo? Midterm na ba yon?
Yes, po.
Doc.
Once a week din ba yon?
Talaga ito na lang binili ko eh. Parang magkano kaya ito?
Sige.
Yes,
Mr.
po.
Steve. Pardon? Never mind na kung hindi nyo masasagot na diretso. Tristisa, do you still have questions? Kasi naka-raise hand ka pa. Okay. So, everything, lahat na-discuss natin. So, ang quiz mamaya, i-reset ko yon from, oras ulit? 7 to 10. Right, mga bata? 7 to 10 i-open ko ha. Not 11:59. 7 to 10 lang. Okay, para it's not too late na. Kasi mahirap din may pasok tayo next time. The next day, 7 o'clock din ang pasok ko. The university ako bukas. Okay? Thank you. If you don't have question, then you may log out. Maintindihan mo maayos. Regarding what?
Hello, regarding an activity po, meron po kasi akong na-miss out. I-ask ko lang po sana if ever there's still a possibility that I could take it po.
Kailan yon?
Noong po September 29.
It's too late na. Siguro, we'll focus na lang for this activity tonight. Ito yung dalawa. Focus on it. Okay?
Okay po. Okay po. Thank you po.
You're welcome. Anak ka. Meron pa bang tanong, Miss Morgia, Kabanglan, and Manalad? Miss Manalad, do you have question? Miss Manalad. Okay. You may log out, Miss Manalad, if you don't have any question.